Hello, everyone, and welcome back to the Mostly Human Show. We're here with episode 3. My name is Adrian. I'm a developer advocate at Cisco DevNet.
And my name is Shereen. I'm also a developer advocate at Cisco DevNet.
So, Shireen, we've covered so far how to fine tune an LLM for networking use cases and how to prepare and format networking data such as configuration files, logs, metrics, design documents and wikis, knowledge bases, and tickets for LLM consumption. In this episode, we're going to take it further and we will talk about where to find these LLMs and how to choose the right one for your networking use cases. You had suggested Hugging Face in episode 1, but how do we differentiate from all of the models it has to offer?
Right. So there are multiple ways to choose which LLM model you want to use based on your technical comfort level and your specific needs. So as a result, you'll most likely be placed in 1 to 2 tiers, as I like to call it. Tier one would be like no code playgrounds. This is for people that aren't like comfortable in like the command line interface. They're usually web-based, and you can just kind of plug in these LLMs and get started testing in minutes. Have you ever heard of LM Studio?
I actually have heard of it. I have it pulled up right here. Um, and we can see here LM Studio is a popular tool that you can use to explore actually Hugging Face LLM models. So I have it installed. If I go under Discover here, there's lots and lots of models that are available, basically all the ones that are on huggingface.co. And if I were to search for a networking one, right, we see that there is one, a networking model Alpaca here, that's been updated, in this case, 15 days ago, right? 66
Mhm.
downloads. So there's not many downloads, but there are custom models specifically built for networking use cases. So this will be one of them. I have installed here several of them, and I've tested actually. I've asked how to configure EIGRP on a Cisco IOS XE device. I've asked this question to multiple models. The networking model right here that I just showed you performed fairly well. It showed me all the options that are, well, most of the options that are available for EIGRP configuration on iOS XE. And then I also asked, right, my Mistral 7 billion parameters cloud chat model. It gave me similar information, but a bit less options for the configuration. Um, has some example scenarios, but not as many options as the networking model that we've just covered previously. And then I've also asked the same question to Quen 3, 4 billion thinking model, right? Exactly the same question. Again, similar to the Mistral one, a bit more options, but still not as comprehensive as the networking specific model that we've showed initially. Um, so that model pretty much gives you the most options and output, right? Because it has been trained for specific network use cases.
Exactly. LM Studio also lets you browse models and adjust parameters like the temperature or the context length. So, for deeper technical evaluation beyond those parameters, you can move on to Hugging Face, um, where you can also find a breadth of different models. In Hugging Face, you can find a leaderboard where you can test the models anonymously and even participate in the rankings for those. This method is perfect for the initial exploration because you get both seeing example outputs on LM Studio, and then you can also see the overall rankings from Hugging Face.
That's surprisingly easy. Is there another option to run LLMs locally on your own servers and machines?
This is where Tier 2 comes in, for those more comfortable with the command line. This addresses your security concerns and gives you complete control of the situation. LM Studio, as we've just seen, is one option of running the LLMs locally on your machine, but another option for those more comfortable with the command line environment is Olama. So for Olama, you just need to open a terminal window, download Olama, and then you'll see a Git-like interface where you can run a few commands to get it up and going. So the first command that you're going to want to run is Olama pull llama 3, or if you don't want to pull llama 3, another option is Olama pull Mistral. Basically, Olama pull whatever LLM model you want to download the models. Then, to run the models, you have to run the command Olama run. So the Olama environment overall is great for scripting and automation because of how lightweight it is. And both tools like Llama 3 and Mistral, oh no. Oh yeah, it is. So both tools, LM Studio and Olama, support models like Llama, Mistral, and dozens of others for local execution.
So what kind of hardware are we talking about for running these LLMs locally, Shireen?
Good question. Smaller quantized models can run on very modest hardware. A model like Llama 3.2 that has about 3 billion parameters, or Phi 3 Mini, which can run on like 8 to 16 gigabytes without a dedicated GPU. If you're looking at a powerful model like Llama 3.1 that has 70 billion parameters, then you'd want something with more power. So there you'd be looking at a case with maybe a GPU with like 24 gigabytes of VRAM, or you can use a CPU inference with more RAM, but that would be a bit slower. If you're looking for rapid prototyping, without local hardware concerns, then you can consider our third tier, free API access. So, Grok is an example of a platform that offers fast inference and it offers a lot of open source models with a generous free tier. GitHub Models is another example of a platform that gives developers free access to various models for testing.
Okay, that's great. So we have places to test. Right now, we're getting to the harder question, which is how do we actually choose the right model for networking use cases? Especially if you're considering several applications such as automated incident response for us, right? Configuration generation, maybe even predictive maintenance alerts, root cause analysis, those types of things.
Great. So now we have some use cases. Let
Yeah.
me walk you through a framework for those use cases. The selection process for that would involve multiple dimensions, and networking has some very unique requirements when you're trying to build a framework to solve these cases. So, the first dimensions would be considering your task complexity and your model capability. Not all networking tasks require the most advanced models. So, more specifically, I think you said log analysis and pattern recognition. When you're looking at something like that, you might start with a smaller, more specialized model, something like Mistral that only has 7 billion parameters, or Llama 3.2 that has about 8 billion parameters. These models can be fine-tuned, and then you're able to identify the anomalies in the syslog data, recognize your error patterns, or maybe flag something unusual that's in your traffic signatures.
Okay, so you say smaller is better for real-time analysis?
Yes. So for certain tasks, they are better for real-time analysis. Latency is critical when it comes to networking. So if you're analyzing logs for security incidents, you can't wait 30 seconds for a response. You need something quicker than that. And so that's where the small models come in with 7 to 13 billion parameters. Typically, they have sub-second inference times, super quick, especially when they're quantized. They can run on decent hardware. However, for complex troubleshooting and root cause analysis, you would need something more sophisticated for the reasoning. So, some models like Claude 3 Sonnet or GPT-4 or Llama 3.1, which has 70 billion parameters, these all have stronger reasoning capabilities. And as a result, they're able to correlate events across multiple systems, understand failures and how they relate to each other, especially as they cascade, and reason through multi step troubleshooting scenarios.
What about configuration generation for network devices? That seems pretty risky. One wrong command could bring down our entire infrastructure.
Absolutely. And this is where domain specific fine tuning becomes crucial. When you have an out of the box model, they generally know basic programming, maybe some basic networking concepts, but they don't understand your specific Cisco iOS syntax nuances or naming conventions, along with any of your security policies. So, when you're trying to develop a configuration generation, you'd want to first start with the model that has strong code generation capabilities, right? So examples of that would be Code Llama or Mistral models have been known to perform well in that area. You can also move on to the next step, which would be to fine tune those models. And you can fine tune it on your organization's validated configurations. So that would be collecting thousands of your approved configs, CLI outputs, change management documentation, anything relevant. And then your model would be able to learn what you've taught it, which is your organization's dialect of networking. After that, then you can implement some strict validation layers. And you never want to apply LLM generated configs without human review and automated syntax, right? For security purposes. So think of the LLM as a highly capable assistant that drafts configurations, but it's not like a completely autonomous operator.
At least not yet. That makes sense. What about keeping the model updated, right? There's network technologies are evolving all the time. There's new protocols, new vulnerabilities, new best practices.
Yes, and not to mention all the updates happening in the AI world as well, right? So this brings us to the concepts of knowledge currency and the importance of implementing some type of RAG architecture in our framework. So LLMs have a knowledge cutoff, and they only know what was in their training data. For dynamic networking environments, you want to implement some type of RAG or retrieval augmented generation. And the way you would do that is instead of solely relying on your model's internal knowledge, you'd want to connect it to your live data sources, which would be like your network documentation, vendor knowledge bases, and recent security bulletins. So when a user asks a question, the system first retrieves the most relevant current information that you've given it, and then feeds that context to the LLM to generate a more informed response for the user.
So that means that it's always working with fresh data, basically.
Yes. And for example, if a network engineer would ask, why is our BGP peer down on this specific router? Then the RAG system would retrieve current BGP status from your monitoring system. Then it would pull the most recent config changes from your change management database. After it has that information, then it's going to reference the vendor documentation about what specific router model it's working with, then check all of the recent security advisories based on that prior information. And then it's going to synthesize everything into a coherent troubleshooting response for the user. Way more reliable than asking an LLM to rely on potentially outdated training data.
This is very helpful, Shireen. So my action plan would be for this week to go and dive further into LM Studio and its capabilities. But also, I want to explore Olama since I love their CLI approach.
Any suggestions on what our viewers can experiment with next?
Yes, they can decide which LLM works best for their use case and what platform they prefer. A nice web UI, a command line, or maybe a rapid prototyping approach. I'd wager a lot of them will go the command line route.
I would too. But we'll see. I'll add, try joining a networking AI community that already exists on Hugging Face or GitHub. There are already a lot of fine-tuned models that exist there with a specification on network log analysis and configuration. So because those have already been shared by others, you don't have to start from scratch. If you gain any ideas of what you would like to see next, please drop comments down below to let us know.
All right. Thank you, everyone, for watching. Wrapping up episode 3. We'll see you on the next one. Thanks, everyone. Take care.